Assalamualaikum warahmatullahi wabarakatuh. My name is Batreesyah. Today I will be presenting how Grab act as disruptive innovation that transformed the traditional taxi industry in Malaysia using Clayton Christensen's disruptive innovation model. This model explains how new innovation entered a market at lower level, target overload user, and eventually displace established industry leader. So this is our group member. So on the left side of the poster, we show the existing taxi system in Malaysia before Grab. Traditional taxi service rely on street hailing, taxi stand, or phone bookings. Payment were mostly cash basis, fare were often uncertain, and passenger experienced long waiting times, especially during peak hour and or bad weather. At this stage, taxi were mainly used by urban commuter and tourists, and the industry was dominated by licensed taxi operator operate under fixed regulation. In the middle section, we highlight the limitation of the traditional taxi system, such as fare uncertainty, limited ability, and absent the driver rating or tracking system. These weaknesses create an opportunity for disruption. In 2014, Grab entered the Malaysian market as a smartphone-based ride-hailing platform. This diagonal error represents Grab disruptive entry, where it started by serving users who valued convenience, transparency, and safety rather than premium taxi service. At the early stage, Grab was mainly adopted by students, young professionals, and tech-savvy users. These users were willing to try a new app-based service because it offered upfront pricing, Grab tracking, and cashless payment, even though it was not yet a mainstream option. Over time, Grab continuously improved its service quality. This includes better app feature, transparent pricing, and expansion into service like GrabCar. As a result, Grab moved into mainstream market that widely adopted by urban community, family, and tourists. This shift causes a major disruption to the traditional taxi industry, forcing taxi operator to either digitalize or lose market share. In conclusion, Grab clearly demonstrates Clayton Christensen's disruptive innovation model. It entered the Malaysian transportation market by targeting overload user, improved its performance over time, and eventually transformed the traditional taxi industry. This shows how technology-derived platform can reshape established industry by focusing on user convenience and unmet needs. Thank you.
Now we move to part 2 of our project, which is the interactive program. For this section, our group developed a program called the Get Fare Calculator using Python. The main objective of this program is to provide simple tool that calculate ride estimate, reflecting Grab's core service as a disruptive technology in the transportation industry. The main purpose of this program is to provide a simple, reliable, and user-friendly tool for estimating ride fare. To use this system, user only need to enter three basic input, which are the start location, the destination, and the distance in kilometers. Based on this input, the system will automatically process data and displays the total fare in Ringgit Malaysia. This allows user to estimate their travel cost quickly and accurately. The Next, I will explain how the system works in terms of logic and design. As shown in this interface mockup, our system is designed with a clean and professional layout to ensure ease of use. The fare calculation is based on a base fare for the first few kilometers, followed by an additional charge for distance. This calculation logic is implemented using if-else statement in C++, which help to keep the program simple, efficient, and easy to understand. By using this approach, we are able to ensure that this system meet the project requirement while remaining relevant to our topic on disruptive technology.
Assalamualaikum and hi, my name is Muhammad Izzat Shakir and I am the group leader of Group 7. Looking at the technical implementation, our Python program is divided into three main parts. First, we have the API section. By using the request library, our code sends a query to open route service to get precise coordinates. Second, the logic section. You can see here in our calculate fare function, we use a mathematical formula where the fare is calculated based on the distance written by the API. We use a base rate of Rm5 ringgit and extra rate Rm1 per each kilometer. Finally, we have the graphical user interface section. We use Tkinter to create a window application. We also add error handling to catch invalid locations to ensure the program always remains stable during the use. As shown in the video demonstration, when we enter the location for start location and end location, the program will execute perfectly without errors. We also included basic validation to ensure that if a user leaves a field blank, the program prompts them to enter the details correctly. This demonstrates a strong and functional system for user interaction. As shown in the video demonstration, when we enter the location for start location and end location, the program will execute perfectly without errors. We also included basic validation to ensure that if a user leaves a field blank, the program prompts them to enter the details correctly. This demonstrates a strong and functional system for user interaction. As shown